Hi, I'm Micah Maddie Orozco, and this is my Module 3 written exam. I had to leave out number 4 because I don't know how to find the LCM in that way, so I'll be deducted for that, but that's okay. I've got the rest of it done, and I'd like to apologize for being absent at the last presentation. Just had a lot going on, and I'm trying to keep up with everything. So here we go on my Module 3 written exam. Let me pull it up here. Okay, so here we go, Module 3 written exam. And this is going to be my divisibility chart, and I'm going to go over all the divisibility rules 2 through 11, and of course it has number 2 already done for us. If the number ends in an even digit, then it is divisible by 2. So you can see my answers on there. Basically, if it's an even digit, it's divisible by 2. That one's pretty easy. And then it's divisible by 3 if the sum of the digits is divisible by 3. Like 6 plus 8 plus 4 and 684 equals 18. 18 divided by 3 equals 6. So it is divisible by 3. And there's my answers for the rest of those. Now it's divisible by 4 if the last 2 digits are divisible by 4. As in 84 is divisible by 4. 4 goes in evenly. And you can see the rest of my answers on those. Now it's divisible by 5 only if the last digit ends in a 5 or a 0. 684 does not end in a 5 or a 0, it ends in 4, so it is not divisible by 5. You can see the rest of my answers there. The only ones that are divisible by 5 are the ones that end in 0s or 5s. It's divisible by 6 if it is an even number and the sum of digits is divisible by 3. So basically, the divisibility rule for 6 is exactly the same as the divisibility rule for 3. So all the answers are going to be the same on there. Now the divisibility rule for 7 is a little bit trickier, and I'm going to show you this separate slide for that because this one is definitely different from the others. It's not as easy as just finding the last couple of digits. And I put that little face there because I got frustrated with this one. So divisibility rules for number 7. You take the last digit and double it, and then you subtract the results from the remaining digits, and if the difference is divisible by 7, then the original number is also divisible by 7. And that's why I put that face there, because it's like, I don't know what you're talking about, it's crazy, but it's really easy. So you take 5151. Now if you subtract 2 from that, it's 5149. And 49 is divided by 7 equals 7. It divides evenly, so it is divisible by 7. So when you work it out, it makes a lot of sense. It just sounds extremely confusing at first. So we go back to our divisibility table. Let me go back to where we left off. Let's see, we go back to 6. Okay, so that one, 684, is not divisible by 7. The only one that is the example that I showed you, because if you subtract the 2 from 51, it's 49 divided by 7 is 7, and so it is divisible. Now, the divisibility rule for 8 is a little bit easier. It's the last 3 digits. If they're divisible by 8, then yes, it is divisible. And honestly, I use a calculator on that one because I didn't know if 684 divided 8 evenly. So sometimes you have to use a calculator. Maybe cheating. Now, the divisibility rule by 9 is if the sum of the digits are divisible by 9. So 6 plus 8 plus 4 equals 18, like we said before. 18 divided by 9 equals 2 evenly, so it is divisible. And there's my answers for the rest of those. The same rule applies for the divisibility for 10, the same way as if it's divisible by 5. It has to end in a 5 or a 0. So you have all the same answers on that one as it is for 5. 11 is also a tricky one, so I'm going to show you my slide that I made for that. This one takes the alternating sums, which this one shows you the highlighted numbers in 8, the highlighted numbers in red, 1 plus 8 plus 3 equals 12, and then the highlighted numbers in blue, 0 plus 1 is 1. You can see how they alternate. 12 minus 1 is 11. 11 divided by 11 is obviously 1, so it is divisible. It's just a little bit more tricky than the other ones. So we go back to this slide, and you can see which ones are divisible by 11. So knowing those rules really helps you out. It's kind of like a shortcut, but some of them you want to double check with a calculator if you're not entirely confident on those. So now we go to this one. This is calculating numbers by canceling out nines. Okay. So basically, when you divide 6,735 divided by 9, you get 748.3. You want to take the remainders of each one, which is a little bit tricky at first. You have to divide them out and then use the remainders. So 245 divided by 9 equals 27.2. You use that remainder too. I highlighted them in red so you can really get a visual on what you need to use. 681 divided by 9 is 75.6. So you use 3 plus 2 plus 6 to get you 11. And then 11 divided by 9 is 1.2. You use that remainder. The 1 doesn't really make much of a difference. You just use the remainder. And then you use the 7,661, divided by 9 is 851.2. They both have their remainder of 2. So it does check out, and you can find that answer by casting out nines. It's almost like a puzzle. A little bit tricky there. Now the other questions they gave us using casting out nines, I showed here just briefly because I don't have time to go over each one. But you can find that the remainders I highlighted in red. And then this one had a remainder of 0.8 and the other one had a remainder of 0.2, so they don't check out casting out nines. And I found that none of them checked out casting out nines, but whenever we did our homework, several of them did. So it's really like a puzzle, and some of them match and some of them don't. Now this one is using the colored rods to find the different factors. And this is a great visual to use with your students, especially if you're teaching 2nd or 3rd grade and they're just now learning how to multiply, they're just learning what factors are. You can use these colored rods to really show them how many numbers go into the whole number. And this one says, show which rods will measure to be the 9 rod. So 9 would equal 3 times 3, which is a multiplication. You can also do 1 times 9 equals 9. And then you can also show which rods measure to be the 6 rod, which would be 1 times 6 equals 6, or 2 times 3 equals 6. This is a very great visual to show that the greatest common divisor of 9 and 6, because you can show them that we didn't use 6 in the previous problem. We used 3s. So that's going to be the greatest common divisor of both 9 and 6, because 9 doesn't go into 6 and 6 doesn't go into 9. 1 goes into both of them, but it's not the greatest one. The greatest one will be 3. And you can show that as a visual using these colored rods. Now this one shows that you put the 10 rod and the 8 rod together to make the 18 train, which I show here, my visuals. 10 plus 8 is 18 with using the rods. And then you can show all the factors of 18. 1 times 10 plus, no, 1 times 18, I'm sorry. 1 times 18 equals 18. 2 times 9 equals 18. And 3 times 6 equals 18. This is showing multiplication, so I guess it will be more 3rd or 4th grade. It's a little more complicated, but you can still use these colored rods to show addition, subtraction. You can use them for all different things in your classroom. These are great tools. And here's an example, just a picture of the colored rods that you can use with your children in your class. They can put them together, they can do addition, subtraction, multiplication, everything. They're a really great tool to show the greatest common divisor. You can put them on one side of the desk to show one number and the other side of the desk to show the other. It makes that visual to really click so they know exactly what you're talking about and it's not just hypothetical numbers. Now this one goes into the gears, and if you really want to show how many revolutions a certain gear will make, then you have to find the least common multiple, which is a little bit different from the greatest common factor. So you have to find the least common multiple, which I found on these, which is 336. And then to find how many more revolutions the small gear has, you divide the least common multiple of 336 by the smallest gear, which is 48, and you find it's 7 revolutions. So when that little gear goes around 7 times, it's going to make that many revolutions. And then the magic squares, which are kind of fun. They're kind of like Sudoku puzzles. I always say that the wrong way, but they're kind of like number puzzles. you have to find which numbers are going to go where. And so I made a whole slide of these. You have to first determine what the magic sum is. So you have to use the integers and the square that's given. You have to add them all together, which all of these equal -27. But then, now that you know that sum, you have to find that it's 3 times the sum, because if you remember, let me go back and show. This, it's 3 times 3. There's 3 columns and 3 rows. So you have to divide that -27 by 3. So let me get back to where we were. So it would be 3x equals -27, which divides both by 3 equals -9. So each row is going to equal -9, and each column is going to equal -9, which is our magic sum. So I started filling in the blanks here. -7 plus 1 plus -3 is -9. -4 plus -6 plus 1 is -9. 0 plus -4 plus -5 is -9. -2 plus -6 plus -1 is -9. You can see how each row across equals -9 and each column down equals -9. That's our magic number, which makes this the magic square. It's just kind of fun, you know, and I like to have fun with math, believe it or not. So that is my written exam for Module 3, and I will see you next time.